Hi everyone, and welcome to my fuels management final project. I apologize in advance if my microphone is terrible. It's very old, but it's the only one I have. So let's get started. I'm going to be comparing a fire suppressed site with a fuel management site and see how they compare in terms of fuel loading, potential fire behavior, so on and so forth. This project takes place in Aiken County, South Carolina, which is where I live, and you can see from the circle there. It is a primarily longleaf pine, upland longleaf pine habitat with mostly ground and surface fuels. The longleaf pine, along with some of the other native trees like the loblolly pine, are very fire adapted, so they actually don't grow foliage very close to the ground, and so we don't really see a lot of crown fires here. This fire regime is a forest and woodland type with understory fires that occur every 8 to 10 years. Both sites for this project are going to be at a place called Hitchcock Woods. It is a privately owned wildland urban interface in Aiken, South Carolina. It's one of the largest, and conveniently for me, it's about 10 minutes from my house. I've actually worked there a few times. It's a really gorgeous place. So about a little over 25 years ago, they developed a management plan for the site in order to reduce the fire hazard to the nearby houses, since it is a wildland urban interface. This plan includes prescribed burning, trail maintenance, invasive species removal, and timber thinning. However, not all sites in these woods are under the same management plan for various reasons, from their distance to the houses to certain aesthetic plants that the county does not want burned down. So we're going to be comparing two sites that have very different management plans. Some of the local flora, you see, like I said, the longleaf and the loblolly pine. There's quite a few pines, very coniferous, and then some shrubs. The kalmia, which is the upper right pink flowers, is a very large flowering bush that's very popular around here because it's quite beautiful, and it actually is important to this project because our fire suppressed site is partially suppressed because the county or powers that be don't want the kalmia to be burned down or altered because they are so aesthetically pleasing. And of course, there's other political factors going on that I don't need to get into. So our two sites, Site 1 is Ridge Mile Track. It is currently under the Fuels Management Plan. Prescribed burns are done on a 2 to 5 year cycle, and in Hitchcock Woods, about 200 to 500 acres are burned each year. So this is one of the sites where they do that. This site was actually burned almost exactly a year ago on May 5th, 2020. And you can see it's got some nice regrowth, but there's still, fire scars, and it's still in that early process. Site 2 is called Pileated Patch. It is currently not included in the fuels management plan for the reasons that I mentioned, and I'm sure more. It's been heavily fire suppressed. There is actually not a record of a fire existing on this site in over 100 years, so it's quite overgrown. It has a very spongy litter and duff layer. When you step on it, it's actually very weirdly soft. There was one mechanical thinning treatment that took place in the mid-1980s, and that is the only fuel management that has happened. So we're going to be comparing these two sites, which I think is going to be really interesting. And this is just a map of Hitchcock Woods, and you can see where each site is. You can also see, if my mouse works, that there's a lot of neighborhoods. These are all residential neighborhoods, golf courses that all border Hitchcock Woods. Another thing to mention is that this area is a very popular horse riding track, essentially. So there's a lot of cross-country horsing. Horsing, sure. In fact, all of these little things are cross-country jumps that have to be maintained by the woods for the riders. They also do a lot of fox hunting here. So you can see that the recreational quality of the woods is something that has to be taken into effect during these management plans. So our objectives for this study are to see if the current fuels management plan at Site 1 significantly reduces fuel loading compared to Site 2. And when I say significantly, I mean that in a t-test, the p-value would be under 0.005%. And also, even if it's not significant, I want to better understand how the fuel loading differs. I'm also going to see So the second objective is whether or not there's a significant difference in litter and duff depth between the two sites. And then our third is what types of available fuels are present at both sites and how do they compare. We're going to use this data to also answer some fire behavior questions, namely, does the current fuel management plan reduce the reaction intensity and flame length of potential fires when compared to our fire suppressed site? Also, how does fire potential differ between these two sites? And in a fire event, how would the behavior of that fire differ in each site? So basically, what kind of fire, how would it burn, how long would it burn, and so on. So for our methods, what I did is a grid pattern, a 70 meter by 70 meter grid drawn over each site. And you'll notice that I say meter instead of foot because I accidentally did this entire study in metric, which just was my mistake, but all of my calculations were converted to feet. So I actually did 50 meter long transects total instead of 50 feet. Anyways, so on these grids, 3 plots were randomly chosen using a random number generator, and then for each transect, 3 random litter and duff measurements were chosen using the same generator. I took measurements of 1 hour, 10 hour, 100 hour, and 1,000 hour fuels, both rotten and sound. For the first 6 meters of the transect, I studied the 1 and 10 hours. For 10 meters, 100, and for 50, the 1,000 hour fuels. So the tools used were a 30-meter tape measure reel, a go-no-go gauge, a clear plastic ruler to measure litter and duff depth. I also used several websites GIS mapping software through Aiken County, Google Earth Pro, and of course the Fuel Fire Tools application. So the results of my fuel loading measurements are here, and I'll discuss them a little bit further, but you can see that in basically every category, pileated patch, which is our fire suppressed site, did have more fuels than our ridge mile. In fact, for rotten fuels, ridge mile did not even have any rotten, whereas there was some on pileated patch, which makes sense when you consider that this was recently burned and this one has not been burned in over 100 years. In doing a t-test, I found that in terms of significant difference, the average litter depth was the only one that went with a p-value under 0.05%, so it was significantly higher litter depth in our suppressed site. I will say that for duff depth, it's pretty close to under 0.05, so while I won't say that it's statistically significant, I think it's still important to point out. And then also that our fuel loading average was actually not as significant as I expected it to be. Using that data, I used the fire fuel tools to kind of look at some fire behavior. So just so you know, fuel bed 190 is our suppressed site, and then 191 is our managed site. So you can see here that our biomass in the suppressed site is quite a bit more, and it has a higher, much higher level of the ground fuels, which I will discuss in a little bit, but I think that's something to point out. And then for our potential fires, while they have similar potential in terms of FCCS, the available fuels at our suppressed site is a bit higher. So when looking at our fire behavior, we can see that our suppressed site has a much higher reaction intensity, as well as a slightly higher flame length and rate of spread versus our suppressed site. And then, so yeah, that's something to point out, is that our reaction intensity is quite a bit higher, and I'm actually surprised by the similar rate of spread, but that's what I calculated. So taking this data, what I found is I think more data is needed, but I do think, based on what I've measured, that the fuel management plan does reduce available fuels to some degree. As I mentioned earlier, in terms of statistical significance, the fuel management plan does significantly reduce litter depth, and I will say that's pretty close to significant with our duff depth. The fire suppressed site has a higher potential for extreme fire events when we look at the reaction intensity, flame length, and rate of spread than the managed site. I also think it's important to point out that the fire suppressed site has a much higher litter and duff material, suggesting that a potential fire event could have a much longer smoldering period. So while both burn hot, the suppressed site will probably burn for much, much longer, while the managed site would probably be over fairly quickly. And from personal experience burning a suppressed or a managed site, the fire does tend to burn through pretty quickly because there's a low level of ground material. So I think that's something that should be considered when discussing our fire suppressed site. So overall, I think additional study of this is needed. Hitchcock Woods, as you saw on the map, is very large, and there are many, many other sites that are both managed and suppressed. So I think it would be really interesting to continue this study and measure many other areas to see if we can get more accurate, or at least more accurate numbers. Of course, the less numbers you have, the less accurate they can be. So I think that would be a really cool thing to do. But overall, I would say that unsurprisingly, a fuel managed site does have a lower risk of extreme fire events and a lower amount of fuel loading. So this is just my works cited. I also want to thank Bennett Tucker, who is the woods manager of Hitchcock Woods, and he was very helpful in getting me set up and finding a site, and just overall very helpful. If anyone has any questions, feel free to leave a comment. Otherwise, thanks for watching.